Good morning, everybody, and welcome to Trig Day 3. I hope so far that this material hasn't been too hard or too confusing, but I know that it is a little bit weird. That's how it is with anything new that you do, especially like Trig. Trig is just kind of an odd, different type of mathematics that we haven't done, and so just to get into it, there's just some of this weirdness. It's kind of like throwing a ball with your left hand if you're right-handed, or the other way around. So what I want to do is I want to try to just kind of review what we've done and take you one step further. So let's talk about this. Okay, first of all, we've talked about that trig, or trigonometry, is all about functions. And functions have an input and an output. And we know that the input of every trig function, and everybody should be screaming this, the measure of an angle. And the output of every trig function is always the ratio of two sides of a right triangle. And that's odd, but that's still true. So that's what we have so far. This is all about functions. Every function's got an input and output. The input's always the measure of an angle, and the output's always the ratio of two sides of a right triangle. And then we get into SOHCAHTOA. And we've talked about SOHCAHTOA a bunch, and so you should feel pretty good about it. SOHCAHTOA, we got to remember what that means. And what that means is means that sine of any angle is equal to OH, the opposite over the hypotenuse. So SOH, SOH. That's where we get that. And ka is referring to the cosine of any angle is equal to the adjacent over the hypotenuse. Again, CAH. And lastly, TOA means that the tangent of any angle is equal to the opposite over the adjacent. TOA. TOA. So if you remember SOHCAHTOA, then it's easy to remember the relationship that each trig function has with the sides of the triangle. So now let's see if we can actually apply that for just a second. And so here's a right triangle, and notice where we got one side that's missing, but we can figure out that side. Because it's a right triangle, we can use the Pythagorean theorem, and we can figure out what that other side is. I'm going to call that side b, lowercase b. And I'm going to go ahead and say, well, 8 squared plus b squared has got to equal 11 squared. Now, I didn't say 8 squared plus 11 squared equals c squared because the hypotenuse, the side opposite of the right angle, always is the one that's by itself, okay? So it's always the two legs squared add up and equal the hypotenuse squared. And so that's why we're doing this. So anyway, 8 squared plus b squared equals 11 squared. That should give you 64 plus b squared is equal to 121. When I subtract the 64, I get that b squared has got to be equal to, if my math is right, 57. And if b squared is 57, another way of looking at that would be to say that b is the square root of 57. So that's how long this side is right here. It's square root of 57. Okay? Now that we got the lengths of all three sides, now we can go ahead and do the rest. I could say, well, let's make sure we know what the sine of angle A is. Well, A is up here, so we got to kind of put ourselves in the position of that side. And if that's the case, then this side is the opposite of angle A, this side is adjacent to angle A, and this side is the hypotenuse, always. So sine of A, sine is opposite over hypotenuse, and therefore that's equal to opposite square root of 57 over hypotenuse, 11. And I can't simplify that. For cosine of A, cosine is always adjacent over hypotenuse. So adjacent to A is 8, and the hypotenuse is still 11. And I can't simplify that either. And then the tangent of A is equal to the opposite over the adjacent. And so therefore, opposite, square root of 57, and the adjacent is 8. And I can't simplify that either. And I could do all of these for angle B as well. And so I'm going to walk through those really quickly. Sine of B, all sines are always opposite over hypotenuse. So sine of angle B, I put myself in this spot, This becomes the opposite side because it's opposite of this angle. This is the adjacent side, square root of 57, and this still is the hypotenuse. So sine of b is opposite over hypotenuse. That's 8 over 11. Sine of, sorry about that, jumped all over the place. Or I'm sorry, cosine of b is going to be adjacent over hypotenuse. And so the cosine of b is then, of course, square root of 57 over 11. And the tangent of b is equal to the opposite over adjacent. And so I look, opposite is 8, adjacent is square root of 57. So that's 8 over the square root of 57. And hopefully you knew those just as well as I know. All right. Then let's talk about the last thing that we did yesterday. The last thing we did yesterday is we actually had these trig functions with an angle plugged in. And I just asked you to grab a calculator and just plug in this value. So if I'm using my scientific calculator, like a graphing calculator, I would type sine and then type 39 degrees, and I close the parentheses and I hit enter. And my answer to this is, let's see, I get that this is equal to 0.629320391, and this decimal actually goes on forever and ever. This is a non-repeating, never-ending decimal. And so that's why it's very typical that we would round this and we say, well, it's about, 0.63 if we round to the nearest 2 places. And let's say we're going to keep rounding to the nearest 3 places. We'll go, okay, so this is about 0.629. Okay, cosine of 47. Now again, if you're using a phone or a different calculator, you'd probably enter 39 and then hit sine. But for a graphing calculator, you type the trig function first. So for the second one, I go cosine of 47, and I get that is about 0.681998, and it just keeps going. So again, I want to round that to 3 decimal places. So I'm going to say, well, that's about 0.682. In tangent, I'm going to say, okay, tangent of 78, and I get that's about 4.7046 ... So that means it's about 4.705. Okay, if I round to the nearest third decimal place, the thousands. And so this is just getting us used to plugging these things into a calculator. Now, the thing I want to point out, the thing that's no different is, notice, here is the input. And the input still is, even down here, the input still is the measure of an angle. And the output right here, here, and here still is the ratio of 2 sides of a right triangle. They just happen to be a ratio of 2 sides that give us a really crazy, ugly decimal. But it's still one side over another, and the result was this decimal. And so hopefully as you did that yesterday, you kind of were able to start making a little bit more sense of that. And so lastly, what we're going to do today is we're going to take those 2 ideas and put them together. We're going to take this idea of looking at SOHCAHTOA and the relationship of the sides of the right triangle to the trig function. And we're going to take this idea of plugging in an actual angle to the trig function, giving us some crazy ugly decimal, and we're going to put them together. Look at this one for me. And this one right here is exemple numero uno. Okay, and so for exemple numero uno, what we have here is, you notice we have 2 sides missing. We don't know x or y. All we know is the hypotenuse. And we know this one angle, 28 degrees. And what I want to show you is that we can figure out both x and y by using this basic trig that you've already done. Nothing extra now. And so watch this. I would simply type in, first I got to start with set up some kind of equation and think, well, I'm looking at from 28 degrees standpoint. I'm looking from that perspective right here. Okay. And I got to go, well, what do I know about x? X is opposite of the 28 degrees. So I've got to have a trig function that involves opposite. Also, I know this side, which is the hypotenuse. So I've got to use a trig function that involves opposite and hypotenuse. Well, that's easy. It's sine. I know that the sine of any angle is always equal to the opposite over the hypotenuse. So in this case, that would mean that the sine of 28 degrees is equal to the opposite x over the hypotenuse, 47. And this is actually an incredibly easy algebra equation to solve. How do we get x all by itself? Well, x is almost by itself. It's just being divided by 47. So back in pre-algebra, we learned inverse operations, and we just have to, if it's being divided by 47, then we need to multiply it by 47. But to keep the equation equal, we have to multiply both sides by 47. So we multiply this side by 47. These two cancel out, and that leaves us with x is equal to 47 times the sine of 28 degrees. So that's what I type into my calculator. Now, if you're using a phone, you'll probably have to type in 28, then hit sine, and then hit times 47. But on my graphing calculator, I can type this all in at one. I can say 47 times the sine of 28 degrees, and I close the parentheses, and I hit enter. And I get that that's equal to 22.0651 ... And so if someone said to me, how long is x? I'd go, well, it's about 22. If I was rounding to the nearest whole number. If I was rounding to the nearest tenth, which is kind of good practice for here, I'll go ahead and say, well, it's about 22.1. Well, that's great. Well, now how can we figure out why? Well, again, let's look at the perspective of being at that 28 degrees. At that 28 degrees, what is y? Y is the adjacent side. And what side do we know? Well, we know the hypotenuse. We also now know the opposite side, x, at 22.1, but this is some decimal approximation that we rounded. So we really don't want to use that value unless we have to. We want to go back to any numbers that were given in the equation, like 47 and 28 degrees. So y is the adjacent side, and we have the hypotenuse. So what trig function are we going to use? We're going to use cosine. And why? Because cosine of any angle is the adjacent over the hypotenuse. So we can say the cosine of 28 degrees is equal to adjacent, which is y, over the hypotenuse, 47. And just like the last equation, this is really easy to solve. We multiply both sides by 47. The 47s cancel out, and we're left with the equation y is equal to 47 times the cosine of 28 degrees. Again, I grab my calculator, I type 47 times the cosine of 28 degrees, close my parentheses, hit enter, and I get that that's equal to 41.49853 ... And so I'd say, well, that's about 41.5. And it's that easy. And so now I actually know these other two sides that I didn't previously know. I know that x is about 22.1, and I know that y is about 41.5. And it's that simple. Let's try it one more time just to make sure you all are getting it. So here's another triangle. What triangle is this? This, of course, is exemple número dos. Okay, so for exemple número dos, let's talk about this. Again, we've got this corner right here. And if we're dealing with that corner, x is the opposite side to that angle. And again, I've been given the hypotenuse. I'm trying to make this really simple and do two problems that are almost exactly the same. So I would know that I'm going to deal with sine because I'm dealing with opposite and hypotenuse. So I say the sine of 59 degrees is equal to, and it's a good reference to go, well, wait a minute, how do I know what this is? Well, you know that sine of any angle is equal to opposite over hypotenuse. I like to have that just so that we can work from that. So I say the sine of 59 degrees is equal to opposite x over hypotenuse, 41. And now I can multiply both sides by 41. Multiply right here, multiply right here. These two cancel out. And I'm left with x is equal to 41 times the sine of 59 degrees. And if I plug that into my calculator, say 41 times the sine of 59 degrees, I get that that's about 35.1438 ... So I'd say, well, for all purposes, that's about 35.1. That's what x is. X is about 35.1. Well, now let's try y. Again, from the perspective of this 59 degrees, y is the adjacent side. I still know the hypotenuse. I don't want to use this new side I just found because it's not a very clean number. It's just an approximated number. So I always want to go back to numbers that were given to me in the problem, like 59 degrees and 41. And so what I'll do is I'll say, all right, I know that cosine of any angle is equal to the adjacent side over the hypotenuse. So I say that the cosine of 59 degrees is equal to adjacent, which is y, over the hypotenuse, 41. Multiply both sides by 41, just like we did last time. The 41s cancel out, and I'm left with y is equal to 41 times the cosine of 59 degrees. Now, so I type that into my calculator, 41 times the cosine of 59 degrees. Remember, if you have a phone and you're doing this, you're probably going to type 59, hit the cosine button, and then hit times 41. But on a graphing calculator, you can just type it just like it's written. I hit enter, and I get, well, that's 21.116561107, ... So you go, how big is that? Well, it's about 21.1. And so there's the answers to our questions. Someone says, well, how big is x? Well, I don't know exactly how big x is, but it's really close to 35.1. And how big is y? Well, again, I don't know exactly, but I know it's really close to 21.1. And there you go. Well, I hope this has been helpful. What I'd like you to do is try these few problems that I've put on the assignment, and hopefully you'll be excellent at this stuff. I'll be doing Zoom tutoring again from noon until 1. So if you see this and you're still loaded with questions, please plan on being there. Otherwise, email me with other questions you have. I hope you all have an awesome day and a great weekend.